I'm Rebecca Vivian, and I co-authored this chapter with my colleagues, Shuchi Grover and Katrina Falkner. So in this chapter, we're really looking at our goal as educators is to help students grow into confident learners and programmers with increased interest and agency in the learning process, ensuring that students have the necessary knowledge and skills to design, build and test their programming solutions, including positive attitudes and beliefs that support the development of resilient learners. So this chapter outlines key knowledge and skills, as well as the positive attitudes, beliefs and mindsets related to programming. It brings teachers up to speed with the fundamentals that underpin programming education, and we support teachers with analogies and a toolkit of strategies that they can use to grow student learning. Additionally, pedagogies must scaffold thinking and programming skills and development of positive mindsets towards computing and programming. This chapter has been developed around the deeper learning framework, so looking at the cognitive domain, which includes students' thinking, reasoning and disciplinary skills, the interpersonal domain, which includes collaboration and communication, the intrapersonal domain, which involves students' beliefs and mindsets, and so on towards programming. In much the same way as in English has rules and conventions for writing, effective coding mandates those unique rules and conventions as well. So we highlight the importance of these and how teachers can guide the development of good practices, pointing to further learning in other chapters. Computational thinking, systems thinking and design thinking underpin the learning of programming or the creation of digital solutions. And we can explicitly integrate the teaching of these skills into computing education to improve learning and build students' capacity in these various ways of thinking. And we present each thinking skill with a breakdown of the stages, the key elements and practical classroom examples at each stage. So as seen on the table here for computational thinking. The goal of programming in classrooms should be to empower students to have control over their learning by building resilience and autonomy in their ability to tackle problems through problem solving, and by building self-efficacy, motivation, good study habits and mindsets. The teacher can design learning activities and environments to really cultivate these practices and mindsets. In making learning environments inclusive, we're not only creating a space where underrepresented groups feel like they belong and can develop interest and a sense of identity in programming, but one where all students may flourish. And we also point to chapter 12, where teachers can learn more about culturally relevant approaches to programming. Programming is not only about communicating to the computer what we want it to do. A large part also involves communicating our code and our programs to humans, and also working alongside others to create solutions. We propose practical ideas for how students can develop and engage these behaviours, for example, code commenting or through feedback loops. And many of the topics overall in this chapter provide a foundation to the fundamental knowledge, skills and attitudes and beliefs that students are to develop through programming. We cite some initial classroom ideas that teachers can implement, but also point to other excellent chapters for deeper learning. And that's all for my chapter. Thank you.